Chapter 2, Section 6, prove angle pair relationships. Last class we did angle and segments. Okay, angles and segments. So now we're doing angle pairs, meaning more than one angle. Flowcharts and paragraph proofs. We will not be using this in class, but it is still good to know. Flowchart proofs use arrows and boxes when you're going through a flowchart. We've seen flowcharts hopefully in English before, but we are not going to be using it for geometry using proofs. We're still using our 2-column proofs, but we're going to see an example in the notes for today. Another one we won't be using, but good to know, is paragraph proofs. It's just using sentences and writing in a paragraph. It's kind of the same information as if you were to do a 2-column proof. But again, we're going to see an example of a paragraph proof in the notes for today. Right angle congruence theorem. Right angle congruence theorem means all right angles are congruent. Yes, this is a theorem you have to remember. You don't have to know the theorem 2.3. Don't worry about that. Just remember right angle congruence theorem. All right angles are congruent. That is by definition. That is what it means. This is a flowchart proof. Looking at my flowchart proof, again, if you think about it, it still has your statements, it still has your reasons, it's just not written using that T-chart that we normally use. So it's using a flowchart using boxes and arrows. Think of it as your statements are in your boxes, your reasons are underneath. This is a flowchart proof. So it says, prove the right angles congruency theorem. This is what we're trying to prove. Given angle 1 and angle 2 are right angles, they want us to prove that angle 1 is congruent to angle 2. So follow along. I'm just going to give this to you as an example using the flowchart proof. It says angle 1 and angle 2 are right angles. That's given. So again, think of it as you still have your statements and your reasons. Anytime you see that something is going from a right angle to 90 degrees, by definition, that is what a right angle means. Right angles are 90-degree angles. That is definition of a right angle. Then I'm going from this statement to this statement. The measure of angle 1 and measure of angle 2. They're calling that transitive, but what's another way that I can state this one? What's another reason that I could give? Any ideas? What's another reason I can use for this? If the measure of angle 1 is 90 degrees, what else is equal to 90 degrees? The measure of angle 2, what would that be called? Any ideas for that one? Starts with an S. Katya? What? Not supplementary, yeah. Not symmetry. I'm not switching the order. It would be considered substitution, okay? I'm substituting it. So last lesson, there was one of the proofs that we did. We said it could be transitive or it could be substitution. Remember that sometimes it could be either or, but sometimes it has to be substitution. Okay, so don't forget substitution is something you can still use. So if I'm going from something equal to something congruent, what reasoning is that? Definition of congruent angles is what you're going to use. All right, now they want us to write it as a 2-column proof. So I have my statements, I have my reasons. I'm going to go ahead and fill in that information. Let's do it together. Looking at it, right angle congruence theorem. All right angles are congruent. Look at what they're giving me. Keep in mind there is no diagram for this. Most of the time you will be giving a diagram. So what is my first one? What is my first reason? Given always, go ahead and write it down. Please do not get that wrong come test or quiz day. Given. Okay, again, I already stated it last time. When you see something going from right angle to 90, what is that? What is the definition of a right angle? Definition of a right angle is that your angle measure is equal to 90 degrees. So what is my second reasoning going to be? Again, I'm going from right angles to 90 degrees. Angle 1 and angle 2 are right angles. So the measure of angle 1 is 90 degrees. The measure of angle 2 is 90 degrees, yes.
Definition of right angles.
That is the definition of right angles. Right angles mean they are going to be 90 degrees. So I'm going to highlight it. I'm going from right angles to 90 degrees. That is by definition of right angles. All right, looking at the third one. What's happening from B to C? How am I getting from B to C? What am I doing? Yeah. No. Yeah. Transitive or substitution. Good. Okay. It could either be transitive, meaning I'm getting rid of that 90, the overlap, or I'm substituting the measure of angle 2 for 90, yes.
Is substitution different from the substitution property?
No, it's the same. Yes.
But aren't they different properties, transitive and substitution?
Is transitive and substitution different? Or what are you asking?
There's a
Okay, this could be either or. Yes, substitution and transitive are different, but certain times you can use transitive and certain times you can only use substitution. But if you're looking at it, remember, what's substituting? Substituting is taking something and replacing it with something else that's equal, right? That's what substitution is. Isn't that what I'm doing for this one? I'm taking out the 90 and substituting it for the measure of angle 2. Transitive, yes, is getting rid of the overlap. So if I were to flip this one around, and instead of writing the measure of angle 1 equals 90 and the measure of angle 2 equals 90, if I were to flip this one around and write it as, I'll do it over here, the measure of angle 1 equals 90. 90 equals the measure of angle 2. Isn't this considered transitive if I were to take this out?
So either one of them works.
Okay, yes, for certain ones.
For this one.
For this one, either one works, yes. For this one, either one's work. But there was one we did yesterday where I think I remember it. Let me see. It was this one where we had one of the steps, or I don't think it was the first step, I think it was the third step, was AM equals MB, and then we had AM plus MB equals AB, and then we had AM plus AM equals AB. Do you remember this one from yesterday?
Yeah.
So with this one, I cannot say that 5, I can't say it's transitive. Okay, I can't say that this one was transitive. So for this one, we had definition of, I'm going to put def, and then 4, we had segment addition postulate. But for 5, I can't say transitive. Why can I not say transitive? Because I'm not canceling anything out. For this one, it has to be substitution. Why? Because I'm substituting my MB for AM. So sometimes it could be either or, but for something like this, it has to be substitution.
Okay, yeah, I get it. So if we had to prove one that could be either or, would it matter which one we wrote?
No, if it's either or and you put, let's say 5 of you put transitive and the rest of you put substitution, I'm going to have to go back and check it and make sure it's correct. So if it's either or, state one or the other, but sometimes it has to be one. It cannot be both, yes. Alright, so now that we understand the difference between substitution and transitive, again, when it's transitive you could still use substitution, but sometimes when it's substitution, you cannot use transitive. So just understand the difference. Okay? Alright, so now that we know that, and we stated it's transitive or substitution, look at from C to D. Look at what's changing. Look at how I'm getting there. I am saying the measure of angle 1 equals the measure of angle 2. And then I'm going from angle 1 is congruent to angle 2. What is that? I'm going from congruency to equality. What reasoning would I have behind that one? Okay. Any ideas? What reasoning would I have behind that one if I'm going from equal to congruent or congruent to equal? Katya? Okay, yes. Definition of congruence. And we're dealing with angles, so it's going to be definition of congruent angles. Remember we did definition of congruent segments, but since we're dealing with angles for this one, it's going to be definition of, I'm just going to use the congruency sign, congruent, and the angle symbol. Definition of congruent angles. All right, by definition, right angle congruency theorem, what does it mean? It means all right angles are congruent. I could have done this one in 2 steps if I wanted to, and I'm going to show you the 2 steps. So you can do in 2 steps. Again, you have to know the definitions. My first one could have been obviously what's given, angle 1 and angle 2 are right angles. That's given. And then my second step, I could have just jumped straight to my answer. The only reason why I could jump straight to here is if you know the definition. If you remember the theorem, right angles congruence theorem, okay? I could have just jumped straight to here. Why? Because right angle congruence theorem states all right angles are congruent. So again, I'm going from angle 1 and angle 2 are right angles. And then I'm going straight to stating they're congruent. That is basically my definition of right angles congruency theorem. Okay, I could have shortened this to right angles just so you see the symbols, so you know what I'm writing in the future. Okay, right angles congruent theorem. So yes, you could have done that, but just kind of showing you how to write out a proof using what we have, you can use that. Congruent supplement theorem. Think of the words. Think of, again, geometry is heavily vocabulary. We know what congruent is. We should know what supplement is. Congruent is when you have 2 angles that are congruent, 2 things that are going to be equal. Supplement means it's 180. So you're adding those 2 angles to equal 180. This theorem states if 2 angles are supplements to the same angle. So that means they're sharing an angle. They're supplement to the same angle. They're sharing it. Then they are congruent. So listen to what this one says. If angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. So again, they're giving me a shared angle. That means my other 2 angles are going to be congruent. So looking at it, so we know both are supplements to angle 2. Okay, they're both supplementary to angle 2. So think of this as, I'm just going to give you measurements just to think about it. If this is 110, this is 70, that gives me 180. And then angle 2 and angle 3 are also sharing it. This is also going to be 70 degrees. So angle 2 is not going to change its measure. Angle 1 and angle 3 are then going to be congruent. Okay, do we all understand what congruent supplement theorem is? Okay, you're given two angles that are being shared, means the other two angles are going to be congruent. All right, looking at this proof, what do we have? It says, prove that two angles supplementary to the same angles are congruent. So I'm going to go ahead and prove it. Look at what's given. You guys had homework yesterday. Some of you were like, I can't believe there's two givens. If they are giving you two givens, you will have two givens. However, for this one, they combined them together. So looking at it, angle 1 and angle 2 are supplements. Angle 3 and angle 2 are supplements. What is my reasoning behind this one? What is my reasoning behind my first? Good. Please do not get that wrong. It will always be given. Given. Okay, who could tell me what is the definition of supplementary angles? What is it? Okay, there's a little bit more than just 180 degrees. They're equal to 180 degrees. What is they? Angles. How many angles? 2. Okay, it has to be 2. So pay attention to where we're going. We have angle 1 and angle 2 are supplements, and angle 3 and angle 2 are supplements. What is the definition of supplementary angles? Two angles added together to equal 180. What do you think my reasoning for 2 is going to be? Any ideas? What is it? What is it? No, not addition postulate. Who's saying it? Someone's saying it. I hear it. Good. That is by definition supplement angles. So yes, good job. For this one is going to be definition of supplementary. Okay, that is by definition what it is. I have my angles that are supplement, and then I'm stating if I add them, they're going to equal 180. So by definition, that is supplementary. All right, now look at 3. How am I going from 2 to 3? What is happening here? What is it?
The table and then substitute.
Okay, so we can call it substitution because we are substituting. Look at what I'm substituting. I'm substituting that 180 that was given for that measure of angle 3 plus the measure of angle 2 because it's also equal. What's another word? Yes. Go ahead and sign up. Transitive. Good. So this one could either be substitution or transitive. So 3 could either be substitution or transitive. Okay, now look at 4. What's happening? How am I getting from 3 to 4? How am I getting from 3 to 4? Is it what?
Subtraction angle 2
Good. So this one is subtraction. Okay. I'm getting rid of that angle 2 by subtracting it to both sides. So subtracting the measure of angle 2, subtracting the measure of angle 2. This one's going to be subtraction POE. Because I'm doing it to both sides of my equal sign. And then the last one, The measure of angle 1 equals the measure of angle 2. And then I'm going to, now my angles are congruent. So which one would this be? What is it? Good. Yes. I'm going from equal to congruent. This is going to be definition of congruent. Are we doing segments or angles? Angles. Definition of congruent angles. Congruent complement theorem. So, same thing as before, except now we're dealing with complement. What's complement mean?
90 degree.
Good, 90-degree angles. So it's the same thing except I'm dealing with 90-degree angles. So congruent complements theorem, if two angles are complements to the same angle, okay, again, I'm dealing with the same angle, then they are congruent. So again, look at what they're giving me. If angle 1 and angle 2 are complementary, and angle 3 and angle 2 are complementary, then angle 1 is congruent to angle 3. Again, with this one, both, that's not useful, both, are complements of angle 2, okay? So both are complements of angle 2. It's the same thing, but we're dealing with complementary angles. Linear pair postulate. Yes, this is another postulate you have to remember. If two angles form a linear pair, then they are supplementary. That's what it means. Remember, linear means it has to be supplementary, and your angles have to be adjacent, meaning right next to each other. What makes these adjacent? This little line right here makes it adjacent. They are directly next to each other. So, linear pair, again, look at what it means. If two angles form a linear pair, then they are supplementary. That is linear pair postulate. So, if angle 1 and angle 2 form a linear pair, angle 1 and angle 2 are supplementary, meaning they'll add up to equal 180. Vertical angles. Definition of vertical angles. Two angles such that the sides of one angle are opposite rays to the sides of the other. So, vertical angles, showing you. Here are my sides of one vertical angle. The other vertical angle has opposite rays. Okay, they're opposite rays, or you can think of them as they are opposite angles. When I say opposite angles, here is a vertical angle, angle 2 and angle 4. And then angle 1 and angle 3 are vertical angles. Okay, do vertical angles have the same measure? Good, yes, vertical angles will have the same measure. All right, vertical angles congruency theorem. Okay, congruency theorem. Vertical angles by definition just means they're opposite angles. Vertical angles congruency theorem states that they are congruent. Vertical angles are congruent, they will have the same measure. Okay, so by definition, vertical angles are opposite angles. Vertical angles congruence theorem states that the vertical angles are congruent. So yes, there is a difference between both of them. There is one by definition and there was one by theorem. It's just stating kind of the same thing, but we're stating that they are congruent. They are stating that they are equal. All right, this is a paragraph proof. Paragraph proof, and we are not doing paragraph proofs. I don't want to have to read all your paragraphs, but this is what a paragraph proof is. So prove that vertical angle congruency theorem. Given angle 5 and angle 7 are vertical angles, prove that they are congruent. So paragraph proof states, angle 5 and angle 7 are vertical angles formed by intersecting lines. So here it is. Here's 5 and 7 formed by intersecting lines. As shown in the diagram, 5 and 6 are linear pairs. They're supplementary and they're adjacent. And 6 and 7 are linear pairs, supplementary and adjacent. Then by linear pair postulate, 5 and 6 are supplementary, and angles 6 and 7 are supplementary. So by congruent supplement theorem, they are congruent. Okay? This is a paragraph proof. I know this is a lot. We will not be doing paragraph proofs. We will just be doing 2-column proofs. So let's go ahead and do this 2-column proof. Looking at it. Prove vertical angles are congruent. Look at my statements. Prove or given angle 5 and angle 7 are vertical angles. Prove that they're congruent. What's my first reasoning for my first statement? Given always. Do not forget that, please. You're going to have given on there. Now look at the next one. Angle 5 and angle 7 are vertical angles. Angle 5 and angle 6 are linear pair. Angle 6 and angle 7 are linear pair. If I'm going from something vertical to linear, what would it be? Vertical to something linear. You guys can look back in your notes. Vertical to something linear. It is a definition of something. Okay, look back. If two angles form a linear pair, okay, what would this one be? Vertical, and we're stating that they're linear pairs. This one's going to be definition of linear pairs. Okay, so 2 is definition of linear pairs. Or just linear pair. Okay, that is the definition of linear pairs. Looking at the diagram, 5 and 6 are linear pairs. 6 and 7 are linear pairs. All right, stating the second one. 5 and 6 are supplementary. So now look what I'm going from. I'm going from these two angles. I'm going from two angles that are stated that they are linear to now I'm stating that they are supplementary. Look back at your notes if you have to. This one's a postulate. If two angles form a linear pair, then they are supplementary. Which postulate is that? I'm not substituting anything. It's not substitution. Think of substitution as if you have equal signs. Okay, something has to equal something else. I'm not substituting anything. If two angles form linear pairs, then they are supplementary. What postulate is that? Leilani? Linear pair postulate. Okay, so 3 would be linear pair postulate. Yes, you have to memorize your postulates and your theorems. I'm going to try and make a document with all of them so you have it. Linear pair postulate. Okay, if I'm going from two angles to form linear pairs, then they are supplementary. That is linear pair postulate. Next. I'm going from supplementary to congruent. Congruent, listen to that word. What is my next reason? What is it? Not definition of congruent angles. You're using definition of congruence when you're going from equal to congruent. I don't have any equal signs. I'm going from supplementary to congruent. Look back at the vocabulary. Look back at the vocabulary of them. Okay, we're dealing with supplementary. Now we're stating they're equal. If angle 5, look at the angles. If angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary, aren't they sharing this one angle? They're sharing one angle. So Katya?
Congruent supplements theorem.
Good. Congruent supplements theorem. Okay, congruent supplements theorem is if two angles are supplement to the same angle, which they are, they're both supplement to angle 6. then they are congruent. That is 4. Congruent, I'm going to use my symbols. Supplementary or supplement. Oops, I have an extra letter in there. I'll just rewrite that. Supplement theorem. Okay, and that is it. Questions on this one? Okay. Example 6 should be on the easier side. Find the value of x. What do I first know about these angles? What are they? What is it, Brandon? They're vertical angles, yes. So, angle TPS is congruent to angle QPR. How do I know they're congruent? They are vertical angles. Okay, so that means the measure of angle TPS is equal to the measure of angle QPR. Go ahead and write your equation and solve for x. All right, checking our work, you should have set it up as 148 equals 3x plus 1. Solving for x, subtract 1 to both sides. I'm going to get 147 equals 3x. Divide both sides by 3. And then if you divide it correctly, yes, x equals 49. Okay, so that one was a little bit on the easier side. Let's go ahead and do the last one. It says classify each statement as true or false. Please read carefully. Looking at number 1, if the measure of angle A and the measure of angle B plus the measure of angle C equals 180, then the angles A, B, and C are supplementary. Is that true or false? True or false? Think of vocabulary, think of definitions. Katya? False. Why would it be false? Because they're 3 angles, and what's the definition of supplementary? Good. 2 angles added together equals 180. So this one is false. And I'm going to state why. Can only be 2 angles for supplementary. Okay, same thing with complementary. It can only be 2 angles. Looking at the next one, vertical angles have the same measure. True or false? True, good. Vertical angles are opposite angles. Vertical angles congruency means that they are congruent, so they are equal. This is true. They do have the same measure. And the last one, if angle 1 and angle 2 are vertical angles, the measure of angle 1 equals 2x plus 8, and the measure of angle 2 equals 3x plus 4, then x equals 14. How would I check if this is true or false? What is it? How would I do it? Solve the angles? Yes, solve it by doing what? Katya? Good. Because they're vertical angles, I'm going to set them equal to each other. So I have 2x plus 8 equals 3x plus 4. Solving it, subtract 2x from both sides. You could do this a different way. It's fine as long as we get the same answer. 8 equals x plus 4, subtract 4. I'm going to get 4 equals x. Is this true or false? This is false. X should not equal 14. X should equal 4. Okay, this is the last lesson. Your study guide or review is already posted. I'm going to post extra review today, and we're going to work on that extra review tomorrow because there's proofs in there that I want us to cover. So it'll be posted today. You guys have 2.6 homework. Please show your work. If you have to solve for X, you have to show your work for that and write out your proofs. Test is Tuesday on the 17th.